मैं कह रहा आ जाइए, मैं तो काम कर रहा हूँ।
वो बना करो भैया,
क्या कर रहा हूँ? पढ़ाऊंगा तू अभी
लाइव क्लास ले रही
है कि लाइव क्लास
रिवीजन कर रहा हूँ लाइव क्लास में। तू पेपर दे दूंगा, एक पेपर दे दूंगा कंपनी में।
हाँ चलो लाइव
लाइव है यूट्यूब पे, ध्यान रखिए। लाइव है यूट्यूब पे
तो क्लास दे रहा हूँ, ले रहा हूँ
दे रहा हूँ। ये रहा रिवीजन कोर्स तो वहाँ है जी। ये आवाज जा रही है,
माइक सोता हूँ कहाँ?
नहीं पता मुझे। हेलो हेलो,
कहाँ जा रही है?
आवाज जा रही है। फिर हम चला यूट्यूब पे लाइव आ गए।
वहाँ जा बोलियो।
हेलो हेलो हेलो,
कितने लेट करे उतना?
थोड़ी सी डिले रह गई है सर्वर में जा रहे हैं।
वो देख रहा था, देख रहा हूँ तू लाइव
नहीं देख रहा हूँ।
ये कहीं
चल आवाज आ रही है पक्की है। Welcome back, guys. We will continue discussing our notes. So we were discussing there are 10 people and we have to arrange 4 of them. And the condition is we have to select 2 always. So what we will do, that first we select always selected 2. So we have to arrange 4. So for arranging 4, how many ways? We have 4 factorial ways to arrange 4 people. So how to select 4 of them? Because 2 are always selected. So to selection of 2 from the 8 and arrangement of 4. So this is arrangement and this is selection. Alright. This is how we do selection. And then so next thing is, let's say 10 person are there. No, 10 chair are there and 4 persons. So number of ways to. So how to do this? 10 chairs and 4 persons. So we select 4 chairs from them and arrange 4 people. So these are the number of ways to sit, to make sit on the chairs, to make the people to make people sit on the chairs. These are the ways. Right? And next is next we if 50, yes, this is very important question. Let's say there are 50 questions, right? All are MCQ and 15 are MSQ questions. MSQ 0 to 4 are choices, and this is only one choice. Only one choice correct. All right. So we know that 4. So number of answer sheets possible. So in this question they asked number of answer sheets possible. So guys, these are the answer sheets here. So for question 1 to 50, 1 2 For question one, how many choices we have? Because only one question is correct. Either one of them is four choices of the MCQ, and one we can leave the question. So 0 to 4, five choices we have. Five choices. Five choices. Five choices. Alright. But from 51, 52.65, for 51, how many choices we have? We have 4C1. We can select, uh, we can leave the question. We don't select any option, or we can select one, or we can select two, or we can select three, or we can select four. So these are the uh, choices we have for 51 question, 51 question, 51 to 65 question, 15 questions of total. So 4C0 is 1 here, 4C1 is like 4 factorial upon 3, 4. 4C2 is 4 into 3 into 2 into 2, 4, 4, 6. Is it 6 here? 6. Then this is also, this is equivalent to this. This is 4. And this is equivalent to this. This is 1. So total how many ways we have? 1, 8, 6, 40, 16. 16 ways. So 16 here into 16 here into 16 dot. So these are the total number of ways. Total number of ways to answer the questions. Alright. This is how we do. Alright, guys. So one next thing is what we say permutation with limited repetition. We have permutation, but we can repeat limited amount of time the data types. Data we can say elements. So this in this we treat that this thing as a multi-set. Let's say this is a set. In set we can't repeat elements, all right? So a b c we can't repeat like this. This is invalid. For multi-set we can repeat elements. A repeat three times, b repeat one time, c repeats two times, and so on. So this is limited repetition of the elements, all right? So what is the number of permutations for this? So this is how many total number of elements we have? 1, 2, 3, 4, 5, 6. So 6 factorial repetition divided by repetition. 2 factorial C, 3 factorial like this. So this is limited repetition. Alright. So on these basis we get some questions. Let's say questions like this is a word Mississippi, MISSI, Mississippi. So how many jumble words are possible from this? So total elements are 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial upon M repeat one times only, I repeat four times, S repeat four times, P repeat two times. So these are the number of jumble words. Okay, this is how we do. And one questions we can get here is let's say let's say there's let's say equation. So there is a word called equation. Equation. So how many jumble word possible? We can say, oh, we want all vowels together. So we have A here, I here, A E I O U here. All the vowels are in the equation. In Q T and N are consonants. Right? So we treat this as one only, element, and two, three, four. So these are four factorial ways to arrange these, and we have five factorial ways to arrange these. Four five factorial into five factorial is the answer. So total number of permutations. Right? Or if right, like this, and some things are there, we can get asked that, let's say, number of zeros is equal to m, and number of ones is equal to n. So number of ways to arrange such that no two ones are together, which means no two ones should be together. How can we do this? First, let's say we have some zeros and we have this the zeros under alternating fashion, and or let's say we have ones. All right. So we are entering zeros here. All right. So there are two cases. Two cases will arise. Let's say this in this case, let's say how many these are one m zeros. So m plus one empty places for ones. All right. Select from m plus one places. Select n places for ones. So here condition is m should be, right, m should be greater than or equal to n. If what if m is less than n? M is less than n. What is this? So 0 0 n is equal to 3. So 1 1 1. This is good. This is good. So only one way possible here. One way possible. But this should be difference of only one. Only one difference. Difference of only one. Right? If this is so, this is not possible, not valid here. Right? And some more things are like uh, we can arrange these zeros. So how many zeros are there? M factorial zeros, but all are identical. So m times. So this is one here. And then select m from m plus one cn and arrange n factorial. So n factorial upon n factorial. This is also one. So this is the true value. Right. Next thing, guys, is so we have six boys. Let's say, let's understand this with a question. We have six boys and five girls. So arrange them in a circle. So this is circle given, right? In alternating fashion, or we can say arrange them no two girls together. No two girls together. Fix the boys here. Boys. How many boys? Six boys. One, two, three, four, five, and six. So we can have girls 1, 2, 3, 4, 5, 6. So 6 places are empty. So we have to select 6 places, right? 6 out of 5. 5 out of 6. These are the ways to select and arrange those girls in 5 factorial fashion. And we can arrange boys also 6 factorial fashion. So these are the total number of ways to do this. Right? So arrange 6 boys, select places for girls, and arrange girls because girls are not identical here, and neither the boys. No two boys together. This is not possible because if in this case we have no two boys together, so let's say 1, 2, 3, 4, 5. Girl here, 1, 2, 3, 4, 5. Boys, how many places? 1, 2, 3, 4, 5. But 5 empty places, and we have only 5 empty places, but we have 6 boys. So this is not possible to put boys in alternating fashion, or we can say in the case where no boys together. So here some conditions arise. So in case of circular, in case of circular, alright, in case of circular, valid alternative fashion only if. So in circular, alternating fashion is valid only if number of boy is equal to number of girls, or we can say number of women is equal to number of men, or anything, any distinct object in this regard. In case of circular, alternative fashion means one boy, one girl, one boy, one girl, one boy, one girl, like this. In case of linear fashion, in case of linear fashion, this is not true. In case of linear, difference between, alright, difference between number of boys minus number of girls should be at most one. Is at most one. Right? So let's discuss here, guys. One is very useful trick we have missed already. Here, what we were doing, we were arranging boys in circular fashion. So we do 6 factorial. But when we arrange any distinct object in a circular fashion, n distinct object, this is n minus 1 factorial. So what we do, we apply circular property. This is called circular property on the boys only, on boys, because we are fixing them first. So this is the answer, correct answer. Or one tip here is only apply one time the circular property here on boys, because we are fixing their position. Alright, we are fixing their position. Alright, and so some things are also variations on this question. Let's say these are saying exactly two girls together. Alright. So first we have to select the two girls 5C2 and we have to arrange them in 2 factorial ways. Alright, 5C2 and 2 factorial. Then rest of the girls are in same manner. So let's say this is work as one unit only. So one unit, one unit, one unit. How many girls were there? There were 5 girls. So now 4 girls are remaining. So do this. So 6 factorial upon 6, 6 factorial upon 6 into uh, 6C4 into 4 factorial. So this was the answer in circular way. Or we can say this is the case of alternating fashion, exactly 2 girls together. And one more case is no matter what, there are 10 students, we can say, or we can say 11 students, in which what we are doing here, that 6 boys and 5 girls, arrange them like that exactly 2 girls are together. So from 5 girls we have to select 2 and arrange them too. And now we have 10 units of girls, or we can say students only. Treat those two as one only, girl 1, girl 2, right? And 10 factorial upon 10, arrange them in a circular fashion. This is also one case. So these are many cases can arise. This is very, we can say, confusing also. Right? So from N select R. We say this NCR. Now one variation is always select X from R. So R always X gets selected. So N minus X, C R minus X. These are the same. And never select X from N. So never select X people, N minus X, C R. And one more property, NCR is equivalent to NCN minus R. This is very important also. Alright. So guys, selecting elements from 2 or more sets. This is very different. So how to select elements from 2 or more sets? Let's say we have 6 boys and 5 girls. There are 2 sets, one set this, one set this. And we have to make team of 5 people, in which 3 boys are there and 2 girls are there. So there are 2 sets. We have to select 5. Alright. So how many boys? 3 boys. So select 3 boys from this and select 2 girls from this and make the team. So 6C3 into 5C2. This is the answer. Right? Now again some very interesting question here. Let's say there are 52 cards. Number of ways to draw two. We can say there are 52 cards and number of ways to draw two what king and two queen in 5 cards drawn. So number of ways to draw 2 king and 2 queen and 5 drawn cards. So we have 52 cards and in which we have 4 kings, 4 queens and 48 rest. Not 48, 48 what? 44 rest, right? So how many ways we can select king is 52 c4. All right, or we can say we can select 4 c2, two kings, 4 4 c2, two queens. But this is not the question is asking. So we have 52 cards and number of ways to draw two king and two queen in 5 cards drawn. All right. We have all right, and we are selecting one card here from here. 44c1. So this is into. This is the possible answer. So we have one set of kings, one set of queens, and one set of different type of cards. Then from kings we can select two, from queens we can select two, and from rest of the cards we can select one card. And these are the total cards, five we can select, and these are the total number of ways how can we select this. Alright. Now guys, we are discussing some more things. Let's say there are number of zeros and ones. What the hell? This is not the question. Question is there are 5 zeros and 15 ones. So how many 20-bit binary in number where every zero is followed by at least one word? How many ways? So we have 5 zeros and 15 ones. 15 ones. So how many 20-bit binary number where each zero is followed by at least one word? So let's say these are 5, 0, 1, 0, 1, 0, 1, 0, 1, and 1, 2, 3, 4, 0, 1, 5, and 1, 1, anything. So we can jumble these words, alright? So this is one type of elements, and this is one type, another type of element, like this. So we can treat it like this. So 5 here. So total are 15 factorial upon 5 factorial are there, and 10 factorial are there. These are total number of ways, right? This is how we can do this type of question. And let's say combinations with, yeah, now we are coming to the real problem. So we can say problems which are being asked in the question examinations. So guys, what we were discussing here is, let's say 28 minutes are gone, and we will take 5 minutes rest, and we will continue again. All right, thank you. हमारे बहुत सारे एनर्जी कोड्स 2030 की डेडलाइन के हिसाब से एलाइन किए गए। साथ 2030 तक हम 500 गीगावाट रिन्यूएबल एनर्जी कैपेसिटी ऐड करना चाहते हैं। जहां आपके प्राइम मिनिस्टर साहब से जुड़ा करेंगे मुझे मेरा नाम है जामनी कहीं भी आप किसी ने करते किसी से भी तो बनाने करते हाँ मोदी मोदी हम इस बात के दिल्ली चुनाव में जीत रहे हैं बिल्कुल पक्का है नरेंद्र मोदी से बिल्कुल आपकी तरफ चले आपको लगता है कि आपने वापस सरप्राइज हुए वो आपकी वजह से तो नरेंद्र मोदी ने इस्लाम की अपनी जो भी लेकिन उसके बाद कोई धंधा नहीं खास कर तो आप ये कहते हैं इसको रास्ता नहीं होना कितने पॉपुलर तो इसकी उसके मेन उसके जो जवाब देती है जो आपको पॉपुलर करते हैं उसके मेन व्यक्ति है मोदी और अमित शाह मैं आपको बताऊं क्योंकि गुजरात में इच्छा नहीं है गुजरात के पॉपुलर सीरियल था 22 लाख को 58 लोग मारे तो नहीं तो जबरदस्त काम किया मुझे याद है कि रोज में मीटिंग बुलाते हैं विषय था ये पत्रकारों से मैं तो स्टडी करता ही एक बता इसके बाद में लिखा हुआ किसी के बाद में मीटिंग है दस मिनट के लिए इसकी बात नहीं हम सब क्या है ना अपने जो मीटिंग बुलाते हैं इसमें दिन जो का रोज के 11 बजे उसमें करना अंदाज निकाला और किसी दिन पूरी नरेंद्र मोदी से I think once you're used to living in India, it becomes even more difficult to accept the systematic way of living in the West. You know, so you're a little like a complete wild. You know, you do whatever you want. You don't have to wear winter clothes in Indian, things like this. Even though the bureaucracy is changing in India, it's becoming very strict.
AI adoption and techno-legal solutions on data privacy. We are developing AI applications for public good. ऐसी क्या इम्पोर्टेंट चीजें हैं जो हम कर सकते हैं हमारी मेंटल हेल्थ को ठीक रखने मतलब the one and the only kita panubo मैं बहुत ही काफी बची मैं हमेशा आसपास पास लेके तो टीचर की पूछता कभी कभी आप बहुत स्ट्रेस हो जाती है जैसे मैं मैथ्स में बिल्कुल नहीं for pulling resources like compute power. It is made available to our startups and researchers at an affordable cost. And India is ready to share its experience and expertise to ensure that AI future is for good and for all. So, I hope that
Alright, guys, welcome back. 10 minutes of the rest. This is too long, I guess. This will be there. Alright, very good. Yes, now we will discuss combinations with unlimited repetition. So, this is also a type of combination problem. Combination with unlimited repetition. When we discuss combination with limited repetition, then we will require some generating function concepts. We will discuss it later if that comes into the notes part, revision part. That those are also important. So the formula here, guys, we will discuss is n minus 1 plus RCR. This is the formula for this. Then what type of problems comes under this type? So number one problem is chocolate problem. We will discuss that. Or we can say identical ball in the box. Next is some is non-negative integer solution, which means greater than or equal to 0. Very non-negative is uh, all right. So for example, we have a question. Let's say we have three variables like this. We have three variables a plus b plus c. This sum should be 10. Okay. Alright. So this is r here. These are n is equal to 3. So what we are saying, a, b or c can get any non-negative value, which means greater than or equal to 0. Alright. So how many number of ways we can assign the values of a, b or c that we get the sum 10. So this is the formula n minus 1 plus RCR, because repetition is unlimited of A, unlimited repetition of B, unlimited repetition of C. This is not so A are identical, B are also identical, C are also identical here. So n is 3 minus 1 plus R is what, 10 C 10, which goes like 12 C 10, which is 12 C 2, which is 11 into 6, 66 is the answer. Mhm. If we are being asked that values of A or B or C should be positive integers, which means not 0. So positive integer means not 0, so then it goes like 1, 1 and 1. So all of the ones becomes 3. So we subtract 3 from 10, so it goes like A plus B plus C is equal to 7. Now we can get any 0, 0 greater is equal to 0. So this was like If you 7 9C2, it's like 8494 54 is the answer. 54 number of ways we can assign values. Right. Other distribution problem here, guys. This is distribution problem. Uh, so distribution problem has several types like we have some boxes, objects, we have some boxes. If objects are distinct, the box is also distinct. So it's called ordered order distribution. If we can say these are distinct, objects are distinct, and the boxes are identical, this is called unordered distribution. So where the order becomes unordered is when the objects are distinct still, but the right, guys. So this is distribution. When distribution becomes unordered, when objects are distinct, still but the boxes becomes identical. Then it's called unordered. So don't get confused. How can we do this? So how can we do this thing? Distinct to identical. So when objects are identical here, identical, and boxes are distinct, right? So what we say is this chocolate problem. We can say identical ball in the box problem. This is the that problem. But what about unordered problem? Unordered distribution. So in this case, why we call this unordered distribution? So, ah, bukan. Ah, so guys, we have to go. So we will stop here only. Thank you so much for joining. We will continue in half hour, 30 minutes. We will continue again. So we will end this stream here only, and we will come back.